Hey GED students, it's GED question of the daytime. And obviously we're still talking about prime and composite numbers, which again falls under the big subject of divisibility. And again, I would say divisibility is the key to understanding so many math concepts that GED students frequently get stuck on. I can't think of a better way to use our time than to play in these waters. So let's see, this problem says, which of the following are composite numbers? So obviously, we need a definition. Last time we had talked about prime numbers, and we had said that a prime number was a number that could be that had exactly two factors, one and itself. And we had even said that composite numbers were just the opposite. Composite numbers, instead of having exactly two factors, have more than two factors. They're not only divisible like all numbers are divisible by one in itself. For example, like 7 is a prime. The only thing you could really divide 7 by is 1 or 7. But 9's not, because even though 9 is divisible by 1 and 9, 1 and itself, it has an additional number. It has more than just these two factors that divide it. 9 is also divisible by the number 3. You can divide 9 perfectly by 3 and get a whole number with no remainder. And so 9 is divisible by 1, 3, and 9, so that makes 9 a composite number. It's composed of other numbers. In this case, 9 is composed of a couple of 3's. So it would be sufficient in order to prove that something was a composite number to just find an additional factor. So looking at A, here's something I notice about 18. I notice that 18 is even. I know that all even numbers are divisible by 2. So 18 is divisible by 1, of course. It's divisible by 18, of course. But I happen to know that it's also divisible by at least 2. Now, is it divisible by more things than that? Yes, it's divisible by 3, 6, 9. But that's not the point. The second I find a third factor, I've proven that another number is composite. It's not necessary for me to go on and find all the factors of 18, just a third factor. So even though 49 is odd, I happen to know it has a third factor, and that's because I have my 7 times tables memorized. And once again, because 7s are the only small prime number that we know that doesn't have a very good divisibility trick. Like, I don't find it very useful. It takes a while. I would just recommend that if you're going to spend time memorizing any of your times tables, at least memorize your 7s. So yeah, I know that 49, of course, is divisible by 1 and 49, but I happen to know that it's also divisible by 7, because 7 times 7 is 49. So 49 is also composite. I was able to find a third factor. Okay, let's look at 29. Of course, 29 is divisible by 1. And it's divisible by 29. But is it divisible by any other number? Don't just assume because you don't know a times table fact it's not divisible. I can fool you guys a lot like that. Do it just like we did with the prime numbers. Check all prime factors. And again, it's only necessary to check prime factors because composite numbers have prime numbers within them. So if you check for the primes, you'll cover all your bases. So check all prime factors up to that halfway point of divisibility. And the halfway point of divisibility is up actually the square root. So we're going to check all the prime factors of all the prime numbers up to the square root of 29 in order to determine if they're factors. I probably shouldn't use that word there. Check all the prime numbers up to the square root of 29 in order to see if they're factors. So of course the square root of 29 would be somewhere between 5 and 6, since the square root of 25 is 5 and the square root of 36 is 6. So I really only have to check 2, 3, and 5. So is 29 divisible by 2? Well, of course it's not, since 29 is odd. Is 29 divisible by 3? Well, even if you don't have your 3 times tables memorized, you could use that lovely trick for divisibility trick for 3's, known as the sum of digits. I'll add together the 2 and the 9. I see I get 11. 11's definitely not on my 3 times table, so neither is 29, so 3 didn't work. And of course, obviously 29 is not divisible by 5 because it doesn't end in a 0 or 5. And so 29 is a prime, not a composite, because I could not find an additional factor. I could not find an additional factor. And I would remind you once again that when finding factors, since factors come in pairs, you only have to check up into the square root, which is the halfway point in factorization. Okay, so now let's try 57. Of course, 57 is divisible by 1 and 57. But is it divisible by any other factors? Again, I should check all the prime numbers up until the square root of 57. So the square root of 57, let's see, it would be somewhere between 7 and 8, since the square root of, I know I'm doing a lot of work in my head, but I'll demonstrate to you what I mean. The square root of 57 is somewhere between the square root of 49 and the square root of 64. So its answer must be somewhere between 7 and 8. So I'll check all my numbers up to about 7, all my prime numbers up to about 7, to see if I can find a factor. So is 57 divisible by 2? Of course it's not, it's odd. And I would say the same for 5. Of course it's not, because it doesn't end in 0 or 5. And if you have your 7 times tables memorized like I asked, you would say of course not. But here's the problem, guys. Don't forget to check for 3s. Most students just brush by, assuming that since they have their 3 times tables memorized, they'll recognize a 3 times table fact when they see one. And you guys won't, especially the large ones. So I'm going to check for 3s using my sum of digits tricks. 5 plus 7 is 12. Is 12 on the 3 times tables? Yeah, 3, 6, 9, 12. So guess what? If the sum of digits is on the 3 times tables, the original number is also on the 3 times tables. 57, even though it feels prime to us, is actually composite. Tricky. Okay, let's, I'm just giving myself space. Let's do one more. Let's test 31. So again, of course, 31 is divisible by 1 and 31. I have to check, I should check all the numbers up until the square root of 31. So since the square root of 31 is somewhere between 25 and 36, it would be between 5 and 6. So I'll test 1. Oh, I'm sorry. Of course, I won't test 1. All numbers are divisible by 1. But I'll test 2, 3, and 5. So is 31 divisible by 2? Of course it's not. It's odd. Is 31 divisible by 3? Well, a quick sum of digits. 3 plus 1 equals 4. 4 is not on the 3 times tables, so neither would 31. That will tell us. And then is 39 divisible by 5? Of course it's not. It doesn't end in 0 or 5. So 31, I could find no extra factor for 31, and so therefore 31 is prime, not composite. Okay, I realize this is a complex skill with a lot of other divisibility going into it. If you're mad at me and you found this particularly confusing, I have a prescription for you. So here's my prescription. 1, get yourself really familiar with, they're either called divisibility tricks or divisibility rules. These are the principles that mathematicians use to check if a number is divisible quickly and easily. You should at least know the ones for 2, 3, 5, and at least know the patterns in the 11 times tables. Even if they don't hold through all the times tables, they'll help you when the 11s are small. Okay, and then my second prescription is memorize your 7s. If you know no other times tables, you should memorize your 7s. And then my third prescription is get good at finding factors. Those were the skills that I was putting together here. The other one that I was doing was estimating square roots. Now, I don't have a video on this yet, but I'm sure some great teacher does. And that's that other skill that I was putting to use there. So a lot of mental math was going on here. Okay, awesome. If you have any question about this or any other GED topic, be sure to drop it in the comments, and I will do my very best to answer it.